When NASA engineer announces a new and revolutionary engine that could take us to the stars, it's easy to get excited. Traveling at or close to the speed of light seems to be a prerequisite for truly comprehensive space exploration, as anything significantly below that would probably limit our species to the solar system or perhaps a handful of other locations in the neighborhood. So in this video, we're going to tell you NASA's Lightspeed engine breaks the laws of physics. The video is going to be amazing, so make sure you stick till the end. Before starting the video, be sure to smash that like button and subscribe to never miss out on any of our videos. When it comes to space, there's a problem with our human drive to go all the places and see all the things. A big problem. It's, well, space. It's way too big. Even traveling at the maximum speed the universe allows, it would take us years to reach our nearest neighboring star. Luckily, some engineers seem to never sleep and keep thinking about big picture issues even in their free time. NASA employee David Burns has recently proposed a concept he calls helical engine, which could theoretically reach 99% the speed of light without any propellant. Burns's proposed helical engine would also be a reactionless drive similar to the EM drive, and so would violate Newton's third law of motion. Dr. Burns from NASA's Marshall Space Flight Center in Alabama unveiled the idea in a head-spinning paper posted to NASA's website. This in-space engine could be used for long-term satellite station keeping without refueling, Dr. Burns writes in his paper. It could also propel spacecraft across interstellar distances, reaching close to the speed of light. He's posted it to the NASA Technical Report server under the heading Helical Engine, and, on paper, it works by exploiting the way mass can change at relativistic speeds. Those close to the speed of light in a vacuum, it has not yet been reviewed by an expert. Understandably, this paper has caused buzz approaching levels seen in the early days of the EM drive, and yes, even some headlines claim the engine could violate the laws of physics. But while this concept is fascinating, it's definitely not going to break physics anytime soon. As a thought experiment to explain his concept, Burns describes a box with a weight inside, threaded on a line, with a spring at each end bouncing the weight back and forth. In a vacuum, such as space, the effect of this would be to wiggle the entire box, with the weight seeming to stand still, like a GIF stabilized around the weight. The engine accelerates ions confined in a loop to moderate relativistic speeds and then varies their velocity to make slight changes to their mass. The engine then moves ions back and forth along the direction of travel to produce thrust, explained Burns. With no moving parts other than ions traveling in a vacuum trapped inside electric and magnetic fields, the engine shows a good deal of promise, at least in theory, but also suffers from a number of not so insignificant practical issues. Today's rockets, like those built by NASA and SpaceX, would need tons of propellants like liquid hydrogen to carry people to Mars and beyond. The problem is, the more fuel you stick on the craft, the heavier it is. Modern propellant tanks are far too bulky to take on interstellar flights. The helical engine gets around this using high-tech particle accelerators like those found in Europe's Large Hadron Collider. Tiny particles are fired at high speed using electromagnets, recycled back around the engine, and fired again. Using a loophole in the laws of physics, the engine could theoretically reach speeds of around 297 million meters per second, according to Dr. Burns. The contraption is just a concept for now, and it's not clear if it would actually work. If someone says it doesn't work, it'll be first to say it was worth a shot, Dr. Burns told New Scientist. The problem with this is that in order to get your rocket going really fast, you have to carry a bunch of fuel with you. The Saturn V, for example, needed to burn about 20 kilograms of fuel for every 1 kilogram of payload just to reach the moon. Things get worse the farther you travel. If you wanted to send a probe to the nearest stars, you'd need about 2,000 kilograms of fuel for every kilogram of payload, and your trip would still take 100,000 years. So it's safe to say that traditional rockets won't get us to the stars. According to the principle of the conservation of momentum, in which the momentum of a system remains constant in the absence of any external forces, this should not be completely possible. But there's a special relativity loophole. Hooray for special relativity! According to special relativity, objects gain mass as they approach light speed, so if you replace the weight with ions and the box with a loop, you can theoretically have the ions moving faster at one end of the loop and slower at the other. But Burns' drive isn't a single closed loop, it's helical like a stretched out spring, hence helical engine. Now, you might argue that Einstein proved Newton wrong, which is true, but Einstein's theory of relativity agrees with Newton's third law. So does quantum theory. If reactionless drives work, then 3 centuries of physics are wrong. Fans of the EM drive argue exactly that. The EM drive works, they say, so Newton's third law is wrong, period. What makes this new helical engine interesting is that rather than simply violating Newton's third law, it tries to play Newton against himself using relativistic mass. You have to be prepared to be embarrassed. It's very difficult to invent something that is new under the sun and actually works. In its simplest terms, the engine works by taking advantage of how mass changes at the speed of light. At such speeds, according to Albert Einstein's theory of relativity, as the ring approaches the end of the box, it'll increase in mass. This means it'll hit harder when it reaches the end of the box, resulting in forward momentum. Burns proposes doing this with particles in a helical particle accelerator, so as the particles go up and down the helix, the rocket moves by Newton's third law. But Burns also proposes accelerating the particles to near light speed as they're at the front of the rocket and slowing them down at the back. Relativity says that the particles moving near the speed of light have greater mass than slower particles, so they're heavier at the front of the rocket than at the rear. Going back to the ball analogy, this would be as if your ball magically gains mass before it hits the front of the rocket and loses mass before it hits the rear. By Newton's laws, this means the ball would give the rocket a bigger push forward than backward, and the rocket would accelerate forward. The engine itself will achieve a similar feat using a particle accelerator and ion particles, but that's the general gist. Chemical, nuclear, and electric propulsion systems produce thrust by accelerating and expelling propellants. Burns writes in his paper, deep space travel is often a trade-off between thrust and large propellant storage tanks that eventually limit performance. The objective of this paper is to introduce and examine a unique engine that uses a closed-cycle propellant. According to New Scientist, the helical chamber would have to be pretty large, around 200 meters, 656 feet long, and 12 meters, 40 feet in diameter to be precise. His design only accelerates the circular motion of the particles, so he assumes their speed forward and backward along the axis of the rocket should remain constant. But in relativity, as the mass of the particles increase, their speed along the axis would slow down. This is due to the relativistic effects of time dilation and length contraction. As a result, the particles give the rocket an equal push at both ends. Einstein's theories don't let you get around Newton. That's what science is all about. That's also why it's worth getting just a little excited when ideas like this are put forward. Most of them will fail, but someday one just might work. We could get to the stars after all, but only if we're willing to keep testing new ideas. Those who say we may never reach the stars may turn out to be right. What is certain, though, is that if we don't try, we'll never know. Let us know your opinion in the comment section below. This was all for today. Hope you liked the video. Don't forget to subscribe to Finding Tech. Stay safe, and we'll be back soon with another video.